Hey kids, we're going to do Unit 6 test review. So what we're going to look at first is in this unit we studied squares and square roots to start with. So we have to remember that squaring the number is just multiplying it by itself. So if I have 2 squared, that means 2 times 2, which equals 4. Finding the square root is the opposite of that. So I would be doing the square root of 4 would equal 2. So remember, that's how you square a number, and that's how you find the square root of a number. So let's do a question. We're going to do one that is not a perfect square, so we can find out which two numbers that are perfect squares that it would be between. So if I was trying to find the square root of 241, that is not a perfect square. So I need to figure out what two perfect squares is it between. Well, I do know that the square root of 225 is 15. And then the square root of, let me see, it was probably going to be 16. I don't have a journal like you have it in your journal, so I'm going to have to multiply. 256 equals 16. So if I look at there, that square root of 241 is between 225 and 256. So I know my answer has to be between 15 and 16. Now, if I want to know, if I want to estimate and get a decimal for this, then I would use like a number line. And let's put 15 and then a halfway mark, which would be 15 and a half, and then 16. And then let's just look, is the square root of 241 closer to 225 or 256? Well, I think it's closer to 256, so then it's going to be closer to 16. So my answer has to be bigger than 15.5. So if I was going to estimate this, I could say 15.6, 15.7, 15.8. Probably wouldn't do 15.9, but it would still be considered correct. So if you're looking for a multiple choice answer from this, just remember that it had to be bigger than 15.5 because it was closer to 16.
Alright, hey guys, this is Mrs. Charles. So we're going to take a look at rational numbers and irrational numbers. So let's remember the characteristics of a rational number. The first one is that it can be written as a fraction, any fraction. As long as a number can be written as a fraction, it is rational. The second characteristic is that the decimal terminates. For example, if you have the fraction fourth, well, you already know that it's rational because it's a fraction. But also, when you convert that to a decimal, you get 25 100ths, and that decimal stops. So it terminates, therefore it is rational. And lastly, if the decimal repeats, it is a rational number. For example, a third is a fraction, so you already know that it's rational, but the decimal form is 0.3 repeating, so therefore it's rational. Let's take a look over at the irrational numbers. Its characteristic is that it cannot be written as a fraction. The decimal goes on and on and on and does not repeat. The biggest example of an irrational number is the pi, because if we convert pi to a decimal, we get 3.14 ... It goes on forever and it does not repeat. Another example is of an irrational number is not a perfect square. So if we look at the square root of 22, that is not a perfect square, therefore it is irrational. Thank you. All right, moving on, let's talk about the Pythagorean theorem. We've been working on this for a few days in class. Everyone should be familiar with it. But remember, it only works on right triangles. You can only use it on a right triangle. And as a refresher, that formula is a squared plus b squared equals c squared, where a and b represent your legs. Those are shorter than the hypotenuse. And the hypotenuse is the long side. It's the side opposite your right angle. That's a good way to always remember it. The hypotenuse is opposite the right angle, and the right angle is where the triangle's legs meet and form an L. So let's take a look at some problems. Alright, so we're going to look at a problem using the Pythagorean theorem. Percy wants to build a fence around his garden, and his garden is the shape of a triangle. So we know that it tells us that one leg is 16 feet, and it tells us that the longest side of the garden is 20 feet. So we automatically know how to set up our triangle. And we're looking to build a fence. So remember, when we're looking to build a fence, we have to know the perimeter, but we have to find the length of the missing side in order to calculate the perimeter. So that is what we're looking for. Since this is a right triangle, we're going to use the Pythagorean theorem to solve it. We're going to label the triangle. Our two legs are A and B, and our hypotenuse is C. We have our formula written down, and now we can go ahead and plug in our values. So 16 squared plus b squared equals 20 squared. Moving through and solving that, 16 squared is 256 plus b squared equals 20 squared, which is 400. Using our algebra, we're going to subtract 256 from both sides to isolate the b squared. So now we're left with b squared equals 144. We're not finished solving. Now we have to take the square root of both sides in order to get b, and we get 12. b equals 12 feet. Now that we know the length of our three sides of the triangle, we can go ahead and find the perimeter. And remember, perimeter is just adding up all of our feet. Our three legs, two legs and a hypotenuse. So 16 plus 12 plus 20 gives us 48 feet. And let's say that the fence that we're going to put around cost $5.35 per foot. In order to find the total cost, we would have to multiply out $5.35 times 48. And we get 24 plus 4, 28. Carry the 2, and that gives us 42. Moving on to the 4, we have 20. Carry the 2. 12 plus 2, 14. 20 plus 1 is 21. Now we're going to add them up. 0, 8, 6, 5, and 2. We're dealing with money here, so we have to look and see what our change is. So moving the decimal 2 places to the left, we get $256.80 as our answer.
Now, so we know the total cost of the fence, $256.80. All of that work, you'll see all that work we had to do. I'm going to show you a shortcut. So don't tell Miss McEwen and don't tell Miss Charles that I told you this. This Miss Sketch is going to tell you a secret about a magic triangle that you can use. So what we have is a magic triangle is the 3, 4, 5 triangle. So we could have cut our work in half on this problem if we had remembered the magic triangle. A magic triangle is where one of the legs is 3, the other leg is 4, and the hypotenuse is 5. Now, any multiples of that will work as well. So let's look at the triangle we had in this problem. We had one side was, one of the legs was 16, and so our triangle in our problem, we had one leg is 16, and we had the hypotenuse as being 20. Now let me tell you my thought process of how I figure out if I've got a magic triangle or not. The first thing I look at is if I ever have a right triangle where my hypotenuse is a multiple of 5, then I say, ooh, I'm going to check and see if this is a magic triangle, so I don't have to do the whole Pythagorean theorem. So let's look, 20 is a multiple of 5, so I have to figure out, well, what times 5 was 20? So I know 4 times 5 was 20. So I have to figure out is, am I going to multiply all the other sides by 4 and it end up being a magic triangle? So let's go and look at 16. Is something times 4 16? Well, 4 times 4 is 16. So this side is like my 4 and the hypotenuse is like my 5 on my magic triangle. So I know that the third side has to be like my 3 on my magic triangle. So if I multiplied my 5 times 4 and then my 4 times 4, then I'm also going to have to multiply my 3 times 4, and that gives me 12, which was the answer we got when we used the whole long Pythagorean theorem. And so if we had used the magic triangle, we would have cut our work in half by finding the perimeter and the money and all of those steps that we had to do. We would have known that that third side was already 12 just by using the magic triangle. So don't forget to write that in your notes so that next time if you want to, you can use the magic triangle. A lot of test writers, they like to use the magic triangle a lot. So if you know it, it'll help you out. Okay, now let's look at another problem that we need to go over for the test. If you have a problem that tells you 1 unit and you need the answers are in different units, then don't forget you have to change your units first. So let's say we had a triangle that was, oh, actually it's not a triangle. It's volume. Remember we had this question on another test before, and so we're throwing it at you again. Remember, volume of a rectangular prism is the area of the base times the height. Well, if I have a rectangular prism, my base is a rectangle, so the area of the base is just length times width. So there's the area of my base, and then I'm multiplying it times the height. Now, if I have, let's see, 144 inches is my length, and 24 inches is my height, and my width is 60 inches. But all my answer choices are in feet. Now, I will tell you one thing. I really don't feel like multiplying 144 times 24, getting that answer, and multiplying it times 60. So I would personally change all my inches to feet first. So to change inches to feet, you know that there's 12 inches in a foot. And that's on your mathematics chart if you forget it. And so how many feet are in 144 inches? Well, 12 into 144 is 12. So that would be 12 feet. So now my length is 12 feet. And then 12 goes into 24 2 times, so my height would be 2 feet. And 12 goes into 60 5 times, so 5 feet would be my width. Now these three numbers are much easier to multiply with, and so I would do 5 times 2 first, which is 10. And 10 times 12 is just add a 0, so it's going to be 120 feet squared. Cubed. Sorry, squared is area, cubed is volume. All right? So don't forget that if your answer choices are in feet and your what you're given in your problem is inches, change everything to feet first before you multiply or do anything. So make sure you read your problems carefully. Like I said, we've had a problem like this before on one of our other tests. Just know it keeps coming back to haunt you over and over and over again. So the last thing that I want to go over, I just don't want you to forget this about Pythagorean theorem, one more thing, is that remember Mr. Pythagoras, how he came up with the Pythagorean theorem, is that he had 3 squares, perfect squares, and he put them together to make a triangle. And that's how he figured out that the area of one square plus the area of another square equals the area of the third square. So if you draw a right triangle, and we're going to draw our 3 squares so that we can actually see the area. And remember, we watched that YouTube video and it took it apart and showed us that's not a square. Tell Miss Charles she needs to learn how to make a square. It is hard, but make it at least look kind of like a square. All right, there we go. So the area of that square, that would be A. If that's side A, then that would be our A squared would fit in here. A squared. And then B squared would be the area inside here. And that added together, gives us the area of that square that would connect to the hypotenuse. Draw a big O square. That's not a square. Okay. Those of you in Miss Charles's class, teach her how to make a square. So Miss McEwen helped Miss Charles make her square so that we know that that big square are those 2 other squares added together. So that's how Pythagoras came up with the Pythagorean theorem. So it's not leg A plus leg B equals the hypotenuse. It's the area of this square plus the area of this square equals the area of the big square. All right, so study hard for your test. Look over the problems that we gave you today, and if you have questions, let us know tomorrow.